This week, we'll be doing scatter plots. Okay. Now, scatter plots are probably some of the most useful and realistic part of mathematics because it actually uses math to predict the future. That's basically what a scatter plot does. Okay. So, but first, I'm going to give you a little bit of background on some skills we need to have before we start talking about them. We need to go over some things that we did before that we might have forgotten. So, let me start off with this. I'm just going to be drawing a lot of graphs by hand today because you'll be doing the same for your homework. So I just want you to see it done so you kind of remember it. So here's just a regular graph. I'm going to number it by ones every other square, both directions. Yeah, 8, 10. Okay, let's say I have a graph with some points that look like this. Zoom in here so you can see that easier. What you're going to be given is a set of points. Okay? A set of points, and the first step is for you to find the line that goes through them. Okay? So, only thing different about this and your actual homework is that the points will not be on a nice straight line. You're going to have to draw a nice straight line on your own that kind of goes through or close to all the points. Okay? So, and then find the equation of that line. So first thing I want to do is remind you, how do you find the equation of a line? Okay, so we have two things we need to find. Okay. Y equals mx plus b. Just remember that b, the y-intercept, is wherever it crosses the y-axis. Okay? So for this example, it crosses at 3. So I know the equation will start with y equals something x and then plus 3. The next step is to find the slope. And for that, you're going to take 2 points, any 2 points on the line, and you want to use what they're called lattice points. And that's where it actually intersects at a corner. Okay? As opposed to something like this where it's not at a corner. These where the two blue lines meet, those are like the corners called lattice points. You always want to pick something that's right on the lattice points or at least close to it. Okay? So I just picked those two. It doesn't matter what 2 points you pick. You do kind of want them away from each other. You don't want to have them like super close. It'll mess up the accuracy of your work. So that's where the little things start I'm talking about. When you're finding these, finding the slope, pick some points that are not right next to each other. Okay, and then you have to calculate the rise and the run. So you probably remember that. How far is it to get from here to here? Right, and how far does it get from here to here? So the rise here's it's at 4, and it's going up to 7, so the rise would be 3. Okay. And the run would be, it's going from 2 to 8. So the run would be 6. From 2 to 8 is 6. So the slope would be rise over run. So review. Rise over run, which in this case equals 3 over 6, which equals 1/2. Okay, so we just reduce it, put it in there. Now, for the purpose of a lot of what you're going to do today, this is going to be a decimal, so we'd actually use 0.5 instead of 1/2. I know a lot of the time we use fractions for the slope, but for purposes today, you'll probably write it as y equals 0.5x plus 3. Okay? And again, here's what this whole thing is all about. Step 1 is to get an equation, and this is going to be an estimated equation from this. You guys are going to have some dots that are not on a straight line that kind of go everywhere, and you're going to draw your own line, which will be different from the line beside you, whoever did it next to you, and your equations will not be the same. Okay? Well, you're going to use this to predict. So think of this as like the present. Everything that we just did, all this right here, is all the present. And then you're going to use it to predict something in the future on this side. So that, right, if I was to ask you, like, what, let's say this was like days or something. And this was like money that we saved. We know how much we saved in 2 days, 4 days, 6 days, 8 days. How much money we would save in 50 days? All right. Well, we could do two things. We could extend this much, much further and keep counting up to 50, which would take forever and a lot of paper. So we don't want to do that. Instead, we want to use our equation right here and plug in 50 for x, and that will allow us to predict what will happen down the line in the future. Okay. So I can just plug in 0.5 and then my x 50 and then plus 3. So I know if I did extend it, right? If I did extend it all the way, get an answer of 27 if I plugged it in. So if I extended this line all the way to 50, it would eventually cross at 27 on the y-axis. And that's, in a sense, what you're going to be doing, is just using it to predict. Okay? So that's what it is in a nutshell. So let me give you a few details, though. Go. And there we go. All right. So this time I'm going to count by 50s on the y-axis, because in reality it's not going to be all these nice numbers all the time. You could have, I mean, if you're talking about the money that company makes, I mean, it could be in the hundreds of thousands or the millions, something really, really big. And we could be plotting over maybe just years. So you can see how the x and the y don't have to be the same as far as what we're counting by. We're counting money here. It could be in the millions, something like that. We're counting years. It could just be 1, 2, 3. Okay. Don't have to be counting the same. And you're going to get this data that is going to not be on a nice straight line. It might look like it's going towards this general area. Okay. Something like this. So this could represent the money that different companies made in 1 year, 2 years, and 3 years. And what you're going to do is try to draw a line that kind of goes through or close to all the points as possible, much as possible. And you want to try to find a nice line that's somewhat in between all of them. So you want to draw it down here, because that's like at the very bottom. You want to draw at the very top up here, but something that pretty much goes close to everything. And so I'm going to use this right here. And this is where it's really going to be different from what we've been doing before. Before, it's like there's one answer. If your answer is not the same as my answer, which is not the same as the person next to you, there's something wrong. You've done it wrong. But with this, you guys can draw these lines differently, and it's only an estimation. With statistics, a lot of it is, you know, when you're predicting the future, it's not an exact science. Some things are, you know, you're able to predict 100%. Most things not. So you guys will have different lines, so your numbers might be different. Okay? So let me go through a more realistic scenario of what you would do. All right, so you have this same question, what's the slope, what's the y-intercept? As you can see here, it does not intersect at a nice number. It's a little bit below 50. So for this one, when you're finding this y-intercept, you'll have to estimate. You might say, that looks like 48. Someone next to you could say, I think it's 47.5. You're both right. So this one, I'm going to go with 48. Okay, and then you want to pick two lattice points if possible, like something that's where the two blue or the four blue boxes intersect. So there's one, and you want to pick them kind of far apart. So there's another one right there. Okay, and notice the rise on here. We're going to go from, this is 125, right? And this is 225. So the rise here is not 1, 2, 3, 4, but it's going from 125 to 225. The rise is 100. So you don't just count the boxes and say, oh, that's the rise, that's the run. That's only if you're counting by ones. If we're counting by anything else, you have to actually look at the numbers. So from here to here, for the run, same idea. All right, we're going from 2 to 4.5, 4.5. How far is it from 2 to 4.5? Okay, that's 2.5. So there's the rise, there's the run. So your slope would be rise over run, 100 divided by 2.5. And you'd probably use a calculator to figure out this decimal. So you pull out a calculator. 40. All right. And it could come out to a decimal. That's fine. It's not going to be some nice number, usually. That just happen that way. And there's the equation of your best fit line, some line that you just estimated. Okay. And again, if I want to find out, well, how much money would they be most likely to make in 20 years? So let's say we continue this down, and we want to know in the future, what happens at 20 years? We're not going to just make the graph go up to 20 and try to make this go higher. You're going to use this equation and say, well, it's going to be 40 times 20 years plus 48. And then we can figure out that's going to be, what, 800 plus 48, which is 848. That's how much money we expected to make, whether it's 848 million or 800 and, whatever units it might be. That's how you use this line of best fit to predict. Okay. Question?
Yeah, how do you get 48 for the y-intercept?
Estimated. I just looked at that and said it's right below 50, so I called it 48.
Oh.
You could have said 47. They're both correct. There's no way of knowing for sure because it's off a graph. Okay, by hand anyway. Okay, and by the way, this is, if you can end up doing this well, you get paid a lot of money. If you can use data points, like for the stock market, to find out will the stock market go up next year, down next year, that's $1 million job right there if you're good at it. So something that's really useful if you happen to have a knack for it and you can look at a lot of things all at once and consider all these different variables. Okay? All right, so let's take a look at your first. Okay, let's take a look at your first graph. Okay. So let's look at the first one. We want to graph this. And it says, with the given data, with the data given, construct a scatter plot and graph paper, draw the line of best fit, and write your equation of the line. So that's what I'm going to walk you through on this first one. It's going to take a little bit of time to make sure we do all the details right. But it's important just to do it right and slow, not hurry up and scratch it out and then have it be wrong. Okay. So the accuracy of which you draw this will determine the accuracy of your answer. If you have crooked lines and it's sloppy, your answer will come out incorrect just because of neatness alone. No mathematics at all. So try to make it as straight as possible. That's why you have a straight edge. Okay? Now, kind of like when we were doing the other stat stuff, you need to look at what your min and max is. Mostly your max. So look at all these numbers. What's the biggest number here? 84. So we need to make a graph that can go up to 84. You don't want to just count 5 squares and say, well, I'll just graph it on these 5. You need to kind of think out ahead of time before you put any of these plots. You know, how many squares should your graph be? So if we need to graph up to 84, that probably means we should go at least to 90. And if we're going to go to 90, how many squares should that be? And keep in mind, the bigger the graph, the more accurate your answer. So you could count by tens, and you'll get up to 90 and 9 squares. You could do that. But if you count by fives, it'll be a bigger graph, and it'll be more accurate. So since it's 5 is, or 10's 2 times is 5, right? So it's going to be, the graph's going to be 2 times as big. So we have, I'm going to graph this all the way up to, I think, 18 or 20 squares. So it's going to be kind of a big graph. But you got to know that ahead of time so you don't just draw your whole graph and then realize, oh, I ran out of room. Erase the whole thing, start all over, just because you didn't draw your graph from the beginning large enough. So I'm going to graph with it being 20 squares. All right, and this is where you can start graphing along with. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. And then just to make it square, let's do 20 horizontally as well. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. There we go. Good. All right, and go ahead and number it. So let's number this 10, 20, 30, 40. Just like we did before, look at it what you're graphing. Let's label it. So you can see here the femur we're going to graph on the X. So we can write down here, I think it's a length of the femur. Yeah, so I'll write down here length of femur. And usually what you're measuring with or measuring by, you put in parentheses. In this case, I think it says centimeters. So in parentheses, put centimeters. On the vertical, let's go ahead and put the other one. So we got length of humerus. Also in centimeters. Now we got that. So you can see how much time and how much work it takes, and we haven't even plotted anything yet. This is just to set it up. But if you don't have the right size graph, the graph is too small, the following will not take place at all in the correct way. It'll be all small or sloppy. Okay, so I'll give you a second to catch up. Okay. Do 59, 70. You got 59, there's 60, so 59 right before it, 70. There we go. 64, 72. Here's 65, so 64, a little bit below it. 72, right about there. And 74, 84. 74, here's 75, so 74, a little bit before it. And 84, here's 85, so a little bit below that. And there you go. So there's all 5. 1, 2, 3, 4, 5 points. Okay. So next you want to draw that line of best fit. And you just kind of eyeball it and you say, I want a line that pretty much goes through or close to all the points. Okay? So you wouldn't just draw a line because these are lined up. You wouldn't just draw a line through those and say, well, let's forget about that. That just doesn't seem to fit with the rest. You definitely want to take into account, well, this line is over here, so it's not going to go straight through all the lines. It'll be maybe a little bit over. Something like that. And if that looks like it's too far up, you think it should be a little bit further down, you can always erase it and maybe get a little bit more accurate. But you're trying to get close to all the points as much as possible. So that one point is not too far away from the line. So that looks like a good line. Okay. Kind of goes through here, close to this one, a little bit below, a little bit above, a little bit below, a little bit above this one. So it's pretty good. And you can see how the line went down here. All right. So our y-intercept is in the negative territory, which is fine. You might have to send it down. So we have to find the equation of this line. And your line, you go ahead and draw your line, it might be different. Your line, just by the way you drew it, it might intersect, you know, something like up here. And your y-intercept might be different just because you had a different take on how to draw the line. So from this point out, your work may not match mine. And you have to be okay with that. Okay? You have to be like, well, it's not going to match perfectly. The calculations are done the same. So that has to be done the same. But the answers and the results may not. Okay? So I'm going to do the work for mine, but your answers are probably different. Okay? Again, I'm going to do my original one. I'm going to find the equation of this one. Okay? Of that one. Alright, so let's try just start off with same old, y equals mx plus b. Alright, zoom out a little bit so we got a little bit of room. And you want to estimate first, what do you think that y-intercept is? Like mine is like, well, this would be -5 right here, so mine's like -3 or -2. I'm going to do -2. So that's the first part. Estimate that y-intercept, and yours will probably be different, and that's okay. Next, go ahead and find a couple lattice points that are not right next to each other, that are kind of spread apart, so you have to look real close. Right. Try to pick something like, for me, you can see right here, that's a nice point. That's kind of a fraction, that's not good. And wait for another one, so here's another one that's good for me. And again, you want them to be somewhat away from each other. You don't want them to be super close. The further they are from each other, the more accurate your equation will be. And we'll have to go through and find the rise and the run. Okay. And so here we have, let's see here, the starting point here is 15, and it's going up to 45. So how far is it from 15 to 45? For me, you subtract them, right? 45 minus 15 is 30. Again, yours will be different. Just subtract the two numbers. Always the bigger minus the smaller, so you get a positive number. So there's my rise. And then my run, it's going to be 15 to 40. So from 15 to 40. 40 minus 15 is 25. Okay. So for the slope, we'll have 30 over 25, and again, we'll probably use in decimals, so go ahead and use calculator and do 30 divided by 25. 1.2. Now, if it comes out to a long decimal, let's just round to the nearest hundredth. So if you got like 1.52812, just round to the nearest hundredth, 2 decimal places. And so 1.2. Okay. So that's the equation I got. And yours will be different, and that's fine. You might have a different slope, you'll have a different y-intercept, that's fine. Yeah. Well, I picked 2 points, right? 2 lattice points, and I just found the rise and the run between those 2 points. And your 2 points could be anywhere here. It's just you want to get them 2 points that intersect, right, where the 2 blue lines intersect. That's what you're looking for. If not, if they don't intersect there 2 times, find 2 points that are really close to doing that, so you can get the most accurate estimation. Yeah, it's kind of uncomfortable, unfamiliar territory when I say, yeah, your answer will be different. You want to look at mine and just copy it down and say, okay, that's the right one. That's not the case here. If you have the same exact thing as I do, I know you didn't do it, because it more likely will not match anybody else's. Of course, with enough people, you will get some overlap, but in the long run, if you do 5 of these, chances are you will not have all 5 match ever. It will be different. Okay? So that is all that work right there was just the first part. Answer the first question. It says to write the equation of your line, right? So my line is y equals 1.2x minus 2.
All your graphs will look different, but it's only going to have like the same.
Nope. Nope. They'll be similar. They'll be close. Like someone else might have picked 2.5. Someone else might pick minus 3. Someone else would have drawn the graph different and got a plus 5, or maybe a 0. Like it's just different depending on how you look at this line and how you drew your line of best fit. So they will be different. Now the answers you'll get in the end will be approximately the same. Now someone else, let's plug it in and I'll show you. So it's going to ask you to predict. So using your equation, estimate the length of a humerus if the femur is 80, right? So remember, the femur is 80. The femur is the x, so you want to make sure you plug in 80 for x. So we got y equals 1.2 times 80 minus 2. And do little calculations here. So I got 1.2 times 80 minus 2. So I got 94 centimeters. So it's almost as if here was what I already knew, and here's my prediction. That if you want to know if the femur is 80, you're predicting that the humerus would be 94. You're just coming up with another point that follows that line. That's your prediction based upon your equation. All right, so that's one problem from begin to end. It started with just making sure you made the graph big enough, plotting the points, choosing a line, estimating your y-intercepts, and calculating a slope, okay? And then using that equation to do a prediction. Okay? Now, usually time is always on the x, so you might look at these and say, well, which one should I put on the x, which one on the y? Usually age or time is always on the x. Okay? Another way of looking at it is that whatever you're trying to predict goes on the y. So here, if we're trying to estimate the height, because we're estimating height, I know that goes on the y, which means my time here should go on the x. And there's fancy names for this, but that's just the way of looking at it when you're trying to decide which one should be on x, which should be on y. Well, which one are you trying to predict? So look at the question. It says estimate the cost. If you're trying to estimate cost, that means you want that on the y-axis. And you'll put things in the right place. Now, sometimes you're graphing like inches versus inches. It won't matter, and you could do it one way or another, and either way is correct. So another thing about stats, just there's so many correct ways of doing things, so many different ways of doing things. It's not always going to be, here's the right way. Okay, so if you kind of gravitate towards that type of thinking, that you like the math, or you think you can do the math, but you're worried about little mistakes, stats is a little bit more forgiving. It kind of lets you give that freedom and creativity. Like, well, you could do it this way or that way. They're both right. Okay? In the end, you don't know until the event actually happens to see if your prediction was right or not. Okay. All right. So give that a go. Try number 2, 3, a little bit as you go. You'll come across a few questions. Ask them as we go. But most people before were able to finish this in class. So you should, aim for that. We got about an hour to do 4 problems. That's 15 minutes per problem. That's ample time. Okay.